Welcome to today's episode. We are exploring a fascinating question. Should we build data centers on the moon? Joining us today is a space technology researcher who has studied this concept in depth. Welcome to the show.
Thank you. It is a topic I find genuinely exciting. The idea sounds unusual, but the technical arguments are surprisingly compelling.
Let us start with the potential advantages. Why would anyone want to put a data center on the moon?
The most significant advantage is natural cooling. The permanently shadowed regions near the lunar poles reach temperatures as low as -200 degrees Celsius. Conventional data centers spend enormous resources on cooling systems. On the moon, that problem is largely solved by the environment itself.
That is remarkable. What other advantages are there?
There is also very little electromagnetic interference from industry or weather. On Earth, electronic signals face constant noise from our dense infrastructure. The moon has no atmosphere, so there is no humidity, no rain, and no corrosive weather affecting hardware components.
I had not considered the weather factor before. What about power supply on the moon?
Solar power is available on the lunar surface. In certain elevated regions near the poles, sunlight is almost continuous throughout the year. These spots are sometimes called peaks of eternal light. They receive sunlight roughly 80% of the time, which is quite reliable.
That sounds very promising. But I imagine there are serious challenges too. What is the biggest technological limitation?
Communication latency is the most critical issue. The moon is roughly 384,000 kilometers from Earth. A signal traveling at the speed of light takes about 1.3 seconds to reach the moon. That means the round-trip delay is nearly 3 seconds, which may seem short but is very significant for computing tasks.
3 seconds may not sound long, but for real-time applications, that kind of delay is completely unacceptable.
Exactly. So a lunar data center would be better suited for storing and archiving data rather than running real-time services.
What about the cost of actually getting hardware up there?
That is currently a major barrier. Launching 1 kilogram of payload to the lunar surface costs millions of dollars today. Building a facility capable of handling commercial data workloads would require hundreds of tons of equipment. The cost is staggering.
Beyond the launch costs, maintaining that equipment remotely must be another serious challenge.
Absolutely. There are no engineers nearby to replace a failed drive. Everything must be designed for extreme durability and remote troubleshooting. Radiation is also a serious concern. Without Earth's protective magnetic field, hardware degrades much faster from cosmic rays and solar particles.
That raises another question. What impact does the moon's extreme temperature range have on electronics?
Sunlit areas reach plus 130 degrees Celsius, while shadowed regions drop to -200. That repeated thermal cycling causes materials to expand and contract until circuits crack.
With no atmosphere at all, how do engineers manage heat dissipation?
Without air, convection cooling becomes completely impossible. Every thermal management system must rely on radiation alone, which makes spacecraft design significantly more complex.
Beyond thermal management, what problems does lunar dust actually cause for hardware?
Lunar regolith is electrically charged and coats every surface, destroying connectors and mechanical parts. Radiation-hardened chips are also essential, but cost far more and perform worse than standard ones.
Would building the data center underground on the moon help protect hardware from temperature cycling and lunar dust?
Underground placement would shield hardware from the extreme thermal cycling between plus 130 and -200 degrees Celsius and keep lunar regolith away from equipment. However, there is no air on the moon, so servers can only be cooled by thermal radiators pointing directly into open space. Underground, those radiators cannot face open space, so server heat accumulates. And construction underground on the moon remains extremely difficult with current technology.
So it simply trades one set of problems for another. There is no easy solution yet. So it seems like the moon is better suited for passive storage rather than active computing right now.
That is a fair assessment. The moon's environment is both an asset and a challenge. We are still decades away from making it practical.
It is a concept that forces us to rethink what a data center actually needs to be.
Precisely. And as launch costs continue to fall, the economics may eventually shift in favor of lunar infrastructure. It is worth watching.
Fascinating insights. Thank you so much for sharing your expertise on this topic today.
My pleasure. These are the kinds of conversations that push technology forward.
That wraps up today's discussion. Until next time, keep exploring big ideas.